Good. So absolutely, the awesome thing about BriForum is you get to say whatever and do whatever at any time. So feel free to do anything. So we're going to talk about the future of virtualization. For me, that's a Xen world. And I'm going to tell you why Xen is still the world's leading hypervisor. And it really comes down to something which Brian and Gabe teed up perfectly just before lunch, related to this really closely interlocked problem of delivery and security. So here we go. So let's light up our Xen motorbike, and I'll show you why we're going to be doing some cool things in the future. So this is the last kind of slide I built for Mark T. Actually, I ended up using it myself at Citrix. So let's jump in with this. I'm going to jump in from a VDI perspective. There is a completely different version of this talk, by the way, which comes from the consumer device perspective, which says that I will buy a device for my mom, and if it can't secure itself, we're done for as a society. Okay? But let's go from the enterprise perspective, because you're all enterprise folk. So the job of IT is to securely empower users on any device. You get it. You've all been to Synergy a bunch of times. By delivering legacy and next-gen apps. Okay, cool. This is the future we have to get to. So are we there yet? Well, you know, the average CIO that I talk to is saying, hey, I'm going to build a VDI private cloud because of all the crap I read in the papers. Okay? And we all swallow this stuff hook, line, and sinker. And I think it's really critical that we as IT people lead the way out of this hole that we're in. See, the problem is you're not seeing the elephant in the room. Okay? The elephant in the room is so big, and we are all culprits in its existence. You see, it's all about me or you. It's the you and user. Okay? And the you and user, IT people they're the worst in general, because they will have admin rights and they'll do crazy stuff. Sometimes I think they need to, but I'm going to show you some examples of crazy things that IT people do. You are no better than the average user. Mark Templeton has this thing which he always says, which is that the drug industry and IT call people users. And you know what? IT people are users too. I want you to walk out of that and to own it. So when I use a device, just like you, it's all about me. It's all about me. It's my stuff, and so on, right? It's all my stuff. And then it's my work, too. So I'm going to turn this into a cloud problem. The cloud problem is a multi-tenancy problem, okay? How many tenants are there on your device? And feel free to answer or throw questions. Well, how many tenants are there on your device? I get what multi-tenancy is in the cloud, right? You would never put a back end of an app in a cloud that did not support multi-tenancy, because then we would fire you. How many tenants are there on your end user device?
2, me and the NSA.
Thank you, Carl. Spot on. Actually, unfortunately, you're wrong. Unfortunately, you're wrong. You see, the VDI world, or at least the story we like to tell in all of these conversations we have at BriForum, including all the MDM stuff and everything else, or EMM stuff, MXM, I like my term better, MXM, is that everything that I do with a device is a threat. That is not work. And that everything I do with work, clearly somebody else has a very clear agenda. So it could be CIO and so on. And this notion of multi-tenancy and 2 tenants is the idea. But it's not true. Every single web page that you ever load into your browser contains code. Every document you open, basically combined with Word, say, is a blob of code. How many tenants are there on your PC? As many as there are websites that you have ever visited. That is the client-side multi-tenancy problem. So how good is your end-user device at solving the multi-tenancy problem? That's the question. It's pretty bad. We all get it. So the challenge really is that you have this battle between me, the user in me, the idiot in me, and what the CIO wants and anybody else who happens to be a tenant on my device. And are we there? Well, where have we got to? We've got to this. We've got to desktop virtualization, and we can make all these cases for centralizing everything and not having client-side state. If there is client-side state, then it's unencrypted and so on. And we get some good benefits. Okay? We get some good benefits. But do we solve the problem? Do we solve the problem? Not in the slightest bit. Okay? That's going to be a key theme of what I'm going to tell you today. We don't solve the problem in the slightest bit. Okay? So it gives us a whole bunch of cool benefits, but it's not enough. It's absolutely not enough. Now, we get some really cool things, and if you've been following this world of VDI and desktop virtualization for long enough, you've bought into this notion that layers of virtualization give us magic. Okay? We can arbitrarily recombine layers of stuff and do things that would never be possible normally. So we have our desktop OS. We always have the latest known good golden image. Okay? Layer of virtualization, we use a self-service of apps, and they can show up and all this stuff, right? App V and so on. You get it. Use the data in one place, same settings on any device, who's or not. Okay, you get manageability, delivery, and compliance. All good. So virtualization today, as we understand it, it addresses a key need to dynamically deliver desktops and apps to users with better compliance, manageability, and security. Have we solved the problem? We haven't even begun to tackle the problem. Okay? And that's what I'm trying to do here is just explain to you that these benefits are required. Okay? Delivery is a requirement for IT. Empower users to be productive. Okay? But there's a big word that is missing here. Okay? So we're not here yet. Okay? We're not quite where we are because the user wants everything. We can't quite give the user what they want. Okay? We still require the user VPNs back in the enterprise network, and we backhaul half the planet's traffic several times. That's why it's good business to be an ISP. And the big word that's missing here is this one here, secure. Okay? So to my mind, delivery and security are absolutely intertwined. Delivering stuff but not securing it is just not acceptable. And we haven't even begun to scratch the surface of the security problem. And by the way, I'm going to try and be fairly assertive here, so I'm hoping some guy's going to eventually say, shut up, and whatever. Okay. So what do we end up with? We end up with the joys of a virtual user experience. And I promised this morning on Twitter that I'd say this twice in my presentation. So here's the user. What does the user say? They say this, which is really, where's that file? Cool. That's where we've got to. So we give the user this. Do users want this? Users just want stuff that works. Users want to be empowered, productive, anywhere. Okay, users do not want this, okay? And we have another problem, which is that this boundary which we have artificially defined, which says that when I am busy being a consumer, I am a threat. When I'm working, I am not, is completely arbitrary. We defined the line in marketing because that's all our technology would let us do. And by the way, the technology doesn't even let us do that. So let's look on that one. You see, a couple of years ago, some poor person at RSA Security opened a work email. See? And suddenly there was some code running on their desktop which turned them into the bad guy. Okay? The bad guys then took the RSA seeds, sent them off someplace, and goodness me, pretty soon after that, Lockheed went down, and a bunch of other folks. So what are we saying here? The end user is the arbiter of security. The end user is the last bastion of security. How pathetic is that? Because we know that there is an idiot in every one of us. So I'll put myself first, but I'm not going to let you get out of this room without owning it too. You are idiots also. Okay? And you will click on the bad thing because I, the bad guy, will make it look perfectly legitimate. And there is no way for you to determine whether it is or is not. And this is the fundamental problem that we have. Now, I could be doing this in the heart of the beautiful virtual desktop that you just built for me, in which case, we're done. Okay? So you give me email in a virtual desktop, give me a browser in a virtual desktop, you're done. Okay? So I think last year we settled the problem, which is that VDI is no more secure than a desktop out in the wild. It possibly helps with compliance, and there are good reasons to centralize data for compliance. But it certainly does not solve a security problem. And that's not enough. That is, ultimately, we as a community have to solve the problem of delivery and security. Otherwise, we're just in deep trouble. Let's look at the rest of the infrastructure that you have. So today, your user has to VPN in. We'll talk more about VPNs a bit later. And then they try and get out. Now, what does the user want to use? Does anybody in here use Twitter? Few people. Anybody use Facebook? Probably everybody, right? Okay. Users want to use stuff out there. But the enterprise proxy won't let you do that. Why? Because the enterprise proxy can say nothing about a tweet shrunk URL that I generated 1 millisecond ago. There is no reputation, therefore you cannot go. And by the way, Twitter is an awesome way to distribute malware. Okay? For that same reason. Now, for me, Twitter is a really powerful work tool because it's where I get to beat up Brian and Gabe and Jack and everybody else. It's just fun, right? So it's a very powerful tool. And also, I want to use stuff that's out there. I want to use SaaS apps in my enterprise. Okay? But your proxy will happily let me go to nbc.com, which is where I was hacked. So your proxy doesn't help at all. Does any of the other junk that the security industry sells you to put on your network help either? The answer is pretty clearly no. Otherwise, the bad guys would not be getting in. But they are, all over the place. And we have to think about why. And we will come back to virtualization and its role in this in just a bit. So here's, I just want to tell you that you guys are all idiots, like me. You know, recently, I had to be on a call with a Fortune 50 bank. And it was during VMware Law. I was doing RSA security conference. So I see this tweet come across my device from the guy who's the data center architect of a Fortune 50 org saying, Simon, remember our 5 p.m. conference call? Here's the number, here's the code. On Twitter. I'm like, dude, you know. Okay, first thing I do is hop on the call and say, how many lines are dialed in? And they said, no, don't worry, everybody we need is on the call. I'm like, that is necessary, but it is not sufficient. Okay. You get the idea. So what's the problem? The problem is that we have legacy practices here, legacy stuff, which really comes out of the 90s, right? Patching the configuration, patch management for the OS. Why do you do that? Because the damn thing's vulnerable. And it's always going to be, and so on, right? And you've got this endpoint security stuff that you buy, and you're required to put in for compliance reasons. God, we really messed it up. I wish we'd done it like HIPAA, but never mind. You're required to have all this endpoint security stuff, which doesn't work either. And so we have this huge churn in IT. And what are you fighting? Me and the way that the application is evolving. The future of the application is out there. It's not in here. It's client to cloud. And so everything that IT does fights that. Okay? And you have to define the user to be the enemy. And that's not the right place to be. Okay? So what is this a problem? This is a problem of decidability. Every day, you have to try and decide whether the user is going to go and surf with a dolphin or a shark. Okay? It's complicated by the fact that the user has always wanted to surf with a dolphin. Always wanted to surf with a dolphin. Okay? And IT has a real challenge here. Okay? So, what is the big problem? You try and put words on it. Mobility, consumerization, collaboration, dealing with the outside. Okay? Trying to decide what the thing is in the wave. Okay? And then where you are, which is out there. Because not many people work only from their office on a protected network with a bunch of legacy stuff that doesn't really protect you in the office anyway. Okay, so these are the three big areas. So here's the next WTF, which stands for what's that fish? Okay, why does it happen? Why do we end up in this horrible problem? You see, in the MDM world, I keep on hearing people talk about putting the good stuff in containers. It's very similar to this argument about the VM. I can build all these magical layers, I can put them together and all this cool stuff. When the device is running, if I take the device, I take the data unencrypted. Because it has to be during execution. The data is unencrypted during execution. Okay? So it just takes one silly thing to happen, and then I've got it all. So putting good stuff in containers, yeah, it kind of doesn't solve the problem at all. You kind of need to protect your data. I am not going to dispute that. That's one half of the problem. But there is no point whatsoever in delivering safely or otherwise enterprise stuff to a client device that is compromised. If that is the case, we're done. Okay. So if I can get you when you are running, I get everything. Whether it's in a little container or not, I get it all. Okay, so what's the IT response to today? It's the response that the Trojans had to the Greeks. We'll build big walls around ourselves, okay? We know the Greeks are, they're all dressed in Greek uniforms. We, the Trojans, will sit inside, okay? And what's the consequence of that? Well, for 10 years, the Trojans had shitty wine, olives, and not much else, right? And they couldn't get out. They weren't a productive society. So what's the corollary? IT is in the way of organizations being productive. Our approach to forcing users into a non-productive mode of behavior screws up the entire org. So IT today is in the business of screwing up productive organizations. And nowhere is it worse than in the most security-conscious users. The other consequence is that ultimately the bad guy will change shape. And someone like my daughter will say, hey, Papa, there's a pony on the beach and no Greeks. Let's bring it in. And then you're done. Okay? It's a problem in decidability. And let's all agree that my hero, Turing, was right. In 1936, building on work from Gödel, Turing proved the halting problem. The halting problem, translated into this context, says it is impossible to decide whether a program is good or bad. The business of detection of good and bad will never succeed. So your anti-malware vendors, your AV vendors, your IDS, IPS, and everybody else vendors are lying to you, and I'm going to be very deliberate about this. They are lying to you when they use the word secure. And the security industry's vocabulary is totally bankrupt because they all just lie. More than that, they try and overemphasize the threat. Turing was right in 1936 before we built the first computer. Okay? It's a decidability problem. We can't do it. So the entire business of trying to decide whether it's a shark is not decidable, and you will never succeed at it because the bad guy has a ton of resources. Think about the Greeks versus the Trojans. The Trojans are sitting in their walls. How much resource have they got? Yeah, whatever. Lousy wine and bad olives. The Greeks have got the whole countryside. The bad guys have got a much bigger cloud than you will ever dream of. Okay. Now, just to make this very concrete, you want to detect a 30-byte worm. How many signatures do you need? Oh, more than there are atoms in the known universe. See? That's the mathematics at work. So the next time your detection vendor of any sort comes into the room, ask them this. Would I ever buy a car that only worked 98.5% of the time? Would you buy one of those? Would you, Mr. Antivirus vendor, would you buy a car that worked 98.5% of the time? The answer should be no, and therefore the product should be free. Okay? Or it should be thrown out. And you guys have to lead this change because the security people won't. There's a whole work practice. The coolest thing about this community, if you think back 10 years when ServerVert first came out, there was a legacy work practice which was install Windows on a server. rack it and stack it, and all of this crap that went on for a long time, right? And we had to translate a whole human work practice to get to where we are now. Much more agile at delivery and all this good stuff. There is a vast security work practice out there. In a large, one of the Fortune 10 banks has 5,000 people in security. Okay? Trying to do what? Oh, reinstall Windows. Okay. It's a problem. Now, what does all the rest of the stuff that the vendors sell you try and do? It does this. Okay? It tries to solve the problem of putting the user back in the box, which effectively in this slide is, hey, user, you're not allowed to leave the beach. I know you know, and you believe that that's a dolphin. You've always wanted to surf with a dolphin your whole life. You've got to stay on the beach. Okay? And that's whitelisting, blacklisting, use the VPN only allowed to do this at certain times on certain days, and lock down the device and give them a miserable experience. That's not the problem that you can solve because the user is already in the wave. Okay? The user has broken out, and that's a battle you've lost already. Okay, so we have to solve it differently. So let's talk about the mobility problem and why the VPN is a real example of a total legacy technology here. See, so I'm off talking to a CIO about mobility and the problems of security, and he says, it's not a problem. I just VPN everything back into the enterprise. And I pull it through my enterprise network where I've got lots and lots of protections. So here's how it looks. You're off at some hotel or doing something like going to a conference. You fire up your browser. Cool. You go to the portal to get onto the internet. What happens right there and then? Bang! 80% of captive portals in certain cities, in certain countries, feed you malware as you try and get onto the internet. There is no secure way to get a network. By the way, your 3G and 4G thing is no more secure than just the unprotected internet. Okay? So what I'm trying to get you to realize is that the device itself has to have a perimeter which is so granular and so narrow that it cannot even trust something simple like what? Oh, the internet infrastructure which is designed to lie to it. Because you went to https://myco.com and this DNS said, yep, that's me, and here's how you get there. And it was designed to lie to you. Okay, so the infrastructure lies. Okay, and then the bad guy follows you wherever you want to go. So if I take the device, I take everything. Wherever you go, I follow everything. Okay, so we sit with this big hole in the middle. And so I'm going to describe to you an entirely different security posture, which will come back to virtualization in a funny way, which is the opposite way than the Trojan model, which is sit inside the walls and try and persuade everybody to be good. Okay? And that's a model which was solved, also a wonderful problem in theoretical computer science, called the Byzantine generals problem. And the Byzantine generals problem, I'm going to phrase it very loosely in computer-y terms, is this. Now we are the attacker. Now we are the attackers. We've got to take this city full of Trojans. And we have all of the problems of an attacker. We have limited number of people. We've got to deal with an evolving battlefield. We have distributed generals. And to win the battle, we have to coordinate all of our troops. But as we send messages to each other, the messengers could be killed. They could work for the other side, and so on and so on and so on. And we're going to develop a system which is Byzantine fault tolerant. There's a theoretical solution to this problem. It goes back to 1980. The original greats who did the work are still at Microsoft. If you can solve the Byzantine fault tolerance problem, you end up with a system which is really pretty solid, no matter what happens. And you should go read the Wikipedia entries. But let me tell you about an organization that has to solve this problem today. Netflix. You see, they don't get to decide whether AWS region Zone 1 East works or not. It sometimes fails. And Netflix still has to get you your movie. Okay? So the cloud stuff, I'm going to try and get you to believe that the cloud side problems are identical to the client side problems. And the technologies are going to be the same too. Okay? You have to solve this problem if you're going to build a Byzantine fault tolerance system like Netflix is trying to build, which is that your movie will always show up. So the general's wearing short sleeve armor. and he's vulnerable. We have to protect him to the death. Okay? So we're off now to build a system which will protect itself to the death. Okay? So we have to protect the general. I'm going to describe what the general is a bit later as we map it back onto systems. If you're a general and you're trying to conduct this battle, how would you do it? You would decouple all of the components of your battle plan into independent, mutually distrustful units. So you'd say, hey, you guys go pound down the door. You guys go fire arrows, and you pikemen go and pike some of the bad guys. You would definitely not say this. You would not say, go do your stuff, all assemble in the middle of the battlefield at 11:30 a.m. sharp, wait till everybody's there, and then we'll advance and kill the enemy. That is the last thing you'd ever do, because now you're mutually dependent, and yeah, things go wrong. Okay. As the general, you would mandate that you control communication between everybody on the battlefield. If the general's not in control, the battle's out of control, you have no hope. All communication has to be controlled. Okay? You would restrict each one of your cohort's access to information based on the need to know in a very granular way. You would definitely never say, hey, you guys go pound down the city door, and just in case we don't see each other later, take a copy of my master plan in your back pocket. Okay? But your PC does this every day. Okay? So you do this. And finally, you would assume that any one of these execution units could be compromised. And you would never, never, never trust it. Notice that there's no implicit model of trust like everything's whitelisted here. Whitelisting is a failure because if I can steal the cert, I can sign the bad stuff as good. All right, so now we're going to go and build one of these, and we're going to use the technologies that you guys are already experts in. Okay? So broadly, the class of technology here is isolation. We're going to isolate all of these independent, mutually distrustful tasks. If this was your kid, right, you'd want that glass wall to hold. That's what we've got to do. Okay? All right, so here I'm going to dive into kind of architecture-y type of diagrams. Here's a desktop. It's going to be a VM later. It could be just a native OS. It could be an iOS-based device or anything else, okay? But it's a thing where I have hardware in the middle. I have an operating system kernel around the outside. There's this thing dying. And then I have, operating system libraries and stuff, and then I have my apps. You're going to see a lot of it. So in general, the problem is this. We're going to add to it different things, and in this VDI world, or desktop virtualization world, I'm going to be very nice to you guys, and I'm going to assume that we've solved all the layering problems. So we're going to add the user data on the fly, profiles, and all this other stuff. And so we can build this system. Great. Bit of a leap of faith. We have an untrusted application, or we have an application that we want to isolate. Now, in this community, when we talk about isolation technologies, we talk AppV or thin app. Okay? But in the security community, you talk about sandboxes. Chrome has a sandbox. Okay? IE has a sandbox. Adobe has a sandbox. Okay? And the goals are very similar. Isolate this thing as much as possible from the rest of the system so we get fewer dependencies, and in the case of sandboxing, make sure that we can protect the system in case this is bad. Okay? That's the goal of isolation. I'm going to show you why this just doesn't have a hope. So everybody has their own technology here, particularly in the application sandboxing world. There are a gazillion of these things. Everybody has one. We're going to assume that they're perfect, by the way. We're going to assume that you've done a further step like Chrome does, which is split the application into two, have an untrusted renderer, maximally deprivileged, and something else which polices it. Okay? So what have we done? Each one of these things, these isolation layers, by the way, they're millions of lines of code by the time you're done. You're going to be poked around inside of AppV or thin app. Those things don't solve the security isolation problem. They're somewhat less. But in general, it's a ton of extra code we've added to the system. So now we built something which is designed to do isolation. Okay? Ideally, isolation on an application basis. But there's a problem here. Okay? All I have to do is get you to go to some bad website, and you will load a font, a poison font. The font will be parsed in the kernel, and you're done. Problem. What happened here? We tried to isolate the system, and we failed. Moreover, in the VDI world, we have some major problems, okay? A lot of the malware that I see nowadays persists in the user profile. So the arguments offered by the vendors for why you want to have this one golden OS, which is you can patch it quickly and everything else, go right ahead, okay? You patch that OS, bring me back the new latest and greatest version, the malware is coming back as part of the user profile. Instantly. And by the way, if your user is using that user profile on another device, maybe a rich client, it's going there too. Profile virtualization is an awesome way to transport malware in the enterprise. Okay, so what was the goal? The goal was to isolate, protect the kernel by isolating malicious tasks or applications from, and it makes sense, right? Because in Windows, this is a massive interface, okay? It's tens of millions of lines of code, and there are so many things that could go wrong there that it seems like a reasonable thing to want to do. Ultimately, the problem is that Windows only uses 2 of the rings of the x86 architecture, but it's a very reasonable thing to want to do. So we've assumed that this stuff works perfectly, right? So we have an application sandbox. It can contain malware. But the malware just had to say, hey, go load me a web page. Boom, we took the kernel directly. So if there is a logic error or a bug in the kernel, and I'm aware of it as the bad guy, you're done. You're done. Now I'm going to get back into a technology domain that you guys are intimately familiar with. Okay? So let's just take it a step further. So I can get the kernel to stumble. Cool. Well, what else could I also do? Actually, it turns out that there's a ton of Windows operating system services that run in user mode. So it's also trivial to escape from any sandbox, including the Chrome sandbox, using one of these Windows services. And we're demonstrating that at Black Hat this year, which is concurrent with this. So bug in CSRSS, hey ho, the application can trivially step out of the sandbox, get arbitrary elevated privileges, and wham, we're done. So this isolation technology that we have today doesn't work. Okay? It doesn't work. Both user mode and kernel escapes are trivial. So how about we do this? And we said, hey, everything that the application is going to want to do, let's call that a task. And Brian and Gabe talked about that just before lunch. Let's wrap stuff up better with all the services and so on it's going to need. And you're going to say to me, I see one of those before. It's called a VM. Right? You've seen these guys before, right? I'm going to put this on a hypervisor, and then we've solved the problem, right? Let's make every app a VM. Cool. What does it end up looking like? It ends up looking like 2 potential models. One would be something like the type 2s that you find on your Mac, so Fusion and so on, or Workstation, whatever it happens to be, or something like XenClient XT, where you've got a type 1 hypervisor on bare metal and a bunch of different VMs for different things. Users don't want this. Users want stuff that works. Okay, remember my first WTF? Where's the file? Okay, users don't want that. So virtualization as a component of a user experience is terrible. Okay, it's another reason why I'm not a fan of this notion of dual personas on mobile devices. Nobody wants it. It screws the user experience up. You end up with a confused user, and therein is its own security problem. I'm not knocking these products for what they do. What they do great. But let's not call them security solutions. The other way you could do it is what Brian and Gabe suggested before lunch, which is I'm going to wrap each app in its own little VM. I'll put an icon on the desktop. I can fool the user that this thing's an app. What have we got now? Well, the user's going to click on that thing. I've got to boot a VM and then go off and do the thing. Well, that sucks if it's a browser. And now how many copies of an operating system am I going to have to manage? Oh my God, did we just blow the manageability problem right out of the ballpark? Okay, Microsoft does this for MedV, for XP compat reasons and everything else, and various other people have done lots of GUI manipulation to make this look like it works, but it doesn't, and the performance sucks. So let's not imagine that hypervisor can solve the problem. We're going to do something different. Now, hypervisors are the clue, though, towards a Byzantine architecture. You see, what you see in the stack as you go out building something like, say, XenClient XT, right? You've got a very small code base that you're dependent on. You can separate out I/O functions into different domains, and you can have each VM in its own different thing. You can decouple these dependencies. So there's certainly a clue here into a way forward, okay? And that is what we're going to go and do. Okay, the answer is essentially an evolution of a hypervisor, possibly to do both. That is, traditional VMs as well as this next thing. And this next thing is going to solve the security problem, or at least take a substantial way towards solving the security problem. We happen to call it a microvisor just because we don't want you to think about VMs. Okay? It's a hypervisor, special kind of hypervisor. Oh gosh, it's Xen. Okay, so let's get out of that. We're going to use all of the magic, which is down there already. VT, there's a VTX, EPT, the enhanced page table walker, the IOMMU if it's present to protect the microvisor, okay, and any other juice that happens to be down there from a hardware security perspective. We're just going to make it Xen, okay, and the nice thing about Xen is it's in the open, and so the right people write the right lines of code, and it's not me you have to believe, and all of those sorts of things. But now what we're going to do is going to completely integrate this thing within the device, make it completely invisible to the user, integrate it within the user experience, and do something very different that you've never seen before. Instantly, on demand, hardware isolate tasks running within the operating system. The operating system will view these as tasks. The user will be absolutely oblivious to the fact that they are there. Okay? That's what a microvisor does. And there's no reason why a hypervisor can't do traditional VMs and slice them up like this. We're going to deal with that a bit later in this talk. So this concept of microvisor is somewhere between this traditional notion of a type 2 and a type 1 and crazy things. I'm going to explain all of that to you with some examples. What are the use cases for this? On the cloud side, there are many. If ever you wanted to have a hypervisor which would achieve maximum density of VMs on a server, this is it, okay? Because I'll get 256 VMs in under 4 gigs of memory on my PC, okay? And there is no server-side hypervisor that can do that. Has security opportunities there too. And on the client, we're going to talk mostly about security. Now, we're not talking only x86 here, okay? We're also talking ARM, and I want to make sure that you get that. And we're not talking only Windows, we're talking Mac, or whatever. It doesn't really matter. Why Xen? You get it. Well-defined trusted computing base. The Xen security modules were not written by me or anybody even related to me. They're written by the right people who do the right kinds of research and have their eyes on the code. Originally, the Xen project inherited all of the IBM Secure Hypervisor code. The current Flask implementation came out of the NSA. Okay, it's good code. And by the way, it's all open. You can go and get it. So this thing is an interesting kind of hypervisor. What I'd like you to think about, you know the Xen model. The hypervisor is tiny. It doesn't contain device drivers. It's just a little thingamajig. But there's this thing called DOM0. DOM0 is this, typically, historically it was 1, but actually that's not true in XenClient or any of these other products that are based on Xen. There's something which gets to access hardware and something actually runs device drivers. That's this thing at the back here. I'm just going to call it your desktop OS for now. That is, somebody's going to do I/O eventually, and we'll do all of that. But everything that deals with the outside world is going to be a magic kind of task dealt with under the auspices of this microvisor. And it's going to hardware isolate these tasks from each other according to something interesting. So every single top-level domain you visit, every tweet you click on, every ad you click on, every document you open from a USB key or every attachment to your email is going to be independently hardware isolated on the CPU using a new Intel VT VMCS for each one of these things. They start at size 0. They are of size 0 when they're created. They are created instantly. How do you do that? The way I'd like you to think of it, because you're all virtualization experts, is think about it this way. I have a thing running. It's called Windows in this example. I want a new one of these, a new hardware isolated task. I'm going to do an instant, in-memory, fast clone of a running system. Take all of the page table state of the running operating system, write it into new Intel VT VMCS, mark all those page table entries as read-only, and I have a new VM. And what is it composed of? Pointers to where we were a few milliseconds ago. Okay? These things don't boot, they just run. So on a Haswell CPU, 10 milliseconds, we're going. And then I can go and do something in it, like run an IE render. Yes?
So how does this differ from what Brian and Gabe were talking about this morning about packaging everything that you need for that thing to work? And
I already have everything I need for it to work. It's called Windows in this example, or it could be Mac OS X. Why do I need another one? It's Windows, for Christ's sakes. It's Windows, and it's unreliable like everything else. Like the Java stack, like the application, it's all going to be vulnerable. So there's no reason trying to package stuff, with independent. Let's just use this magic of hardware isolation, which comes for free with the CPU. You're already heating up and cooling down those transistors. They're there, right? Let's use that to hardware isolate these tasks from one another in the CPU.
So you're talking, this is all hardware here, where they're talking it's all software.
There's no need for extra copies of Windows. It's just Windows, okay? That is, and now, so this is a very interesting concept. And so what can I do? If I imagine I'm in one of these, this is a tab in my browser. This is another tab in my browser. What do I see if I'm in there? I see all of Windows. I can do anything, okay? Hardware isolated, but I'm going to create them according to a very strict segregation according to least privilege. Remember my Byzantine general. So we're going to go into that. Okay? So the operating system knows no different. These are just tasks. Okay? But they have a world which I create for them, and I can arbitrarily mess with their heads. Right? That's the benefit of virtualization. I can mess with your head, right? So let's just say I'm in the heart of your data center, and I want to browse to Facebook. I'm plugged into the physical LAN. I'm going to put this as this task, which is the tab in your browser. Go to Facebook. What files do you need in the file system for Facebook? One, the cookie for facebook.com. Or maybe you need some DOM storage, but that's it. That's all you need. By the way, that's all that will be there. Why? Because I created the file system for this thing. I have the abstraction. Okay. What network do you need if you're going to facebook.com? You need the untrusted worldwide web. If you ever try and do a DNS query for anything on my intranet, or any of my high-value SaaS sites, or my trusted sites, or my user's bank, I'm going to throw it away. If you try and hand number an IP datagram and send it there, I'm going to throw that away too. Why? Now, take everything you know about software-defined networking and put it at the heart of this device. There are 256 VMs here. I own the network. Okay? And I get to do crazy stuff for them. So if you want to look at a PDF document, what file do you need in the file system? You only need the PDF, nothing else. Nothing else shall be there, okay? And what network do you need? Oh, nothing. Because when my PDFs run on the internet, it's not good. Okay, now, this is static least privilege. Does that work with the semantics of the application called Facebook? Like, I want to download and save a photograph? No. So we have to solve a dynamic least privilege problem too. And that's the next problem. Okay. So how does a micro VM interact with the rest of the world? There are 3 service abstractions. And by the way, this would be true in any implementation of this thing. I want to be clear that what I'm talking about here is Xen. And there are other implementations coming. Technology moves forward. There are other vendors doing this sort of stuff. But the abstractions you need are going to be these, okay? So the icon here for desktop services is very deliberate. I want you to think RDP. How does a micro VM get access to keystrokes from the user? How to get access to any USB device, right? Like that. By the way, Facebook does not need my webcam. It doesn't need anything. It needs no devices whatsoever. In fact, this model is not a device-centric model. We have no device drivers. We're not trying to put virtual block and virtual packet drivers into a VM. It's not that at all. It's down to an object that's useful, a file. When that Facebook task wants to open its file, what will happen? It will take a hardware-forced VM exit off the CPU. Intel does all that for me. At which point, the microvisor gets to implement dynamic least privilege. What is that? So, here I am, just a virtualization guy, start reading all the security literature. The security guys call this thing in the middle a least privilege separation kernel. Okay? It's a dynamic least privilege separation kernel which does only one thing, and it's very simple. The Windows OS, same for Mac, only uses 2 of the 4 rings of hardware isolation available on the CPU. Intel gave me ring -1. That's what VT is, ring -1. Yay! Grab ring -1, and I have a hardware implementation. Basically, hardware will defend that boundary, which is how you get to my separation kernel. Okay? That's what the security people call this. And any interaction with any one of these things to get to a network, to get to a file, save a file, get a file, is going to require that you go to this least privilege, go through this least privilege enforcement on a dynamic basis. And that's where you implement policy. So all of the models which would be, say, SE Linux Mac, get enforced right here. But you could do it just as well out of AD or any other form of policy manager, right? That is, in order to get out, you have to do this. And so what can you do in terms of code surface? Well, we know what the code surface is. The code surface of the hypervisor is about 100,000 lines of code. And still, the code surface of these enlightenments, and I use the term very deliberately because you know what the term enlightenment means in Hyper-V context, right? Enlightened drivers, or the enlightened virtual block and virtual disk drivers that Microsoft gives you. The enlightenments that we add here are higher up. They're at the file level, or at the network service level, okay? They're simple. They use standard operating system APIs and abstractions, and they're order 10,000 lines of code. So what do we do? Through the simple addition of this additional ring of protection, we went from a desktop of, say, 50 million lines of code to something where you have a vulnerability surface of order 10,000 lines of code. And you want to break through this thing, you're going to break the CPU. It's pretty hard. So what do these things look like? The task goes into what you would think of as a VM. It's running courtesy of the microvisor. We don't worry with virtualized device abstractions because we don't care about device abstractions here. We care about enlightenments, least privileged enlightenments that allow me to deal with things like files and services that the network's going to want to use. And there's a little bit of logic there, which is how I control tasks. The desktop OS is unchanged. The services that are going to help enforce least privilege just run in user space. And so in that rate, you're going to think, oh, there are some aspects of this which are a little bit familiar from a traditional type 2 hypervisor, such as Fusion. And then there are a couple of enforcement points that we just add. Again, things like file system filter drivers and various other things. You just drop into the operating system, and you're done. And the hardware is driven by the desktop OS. No need to go and try and find Linux drivers for your PC hardware or whatever it happens to be, or your Mac hardware, because that's never going to happen. Okay. So how does it work? You click on an attachment to your email. That's an untrusted file, forces a micro-VM to get created, and the only way that you can get in or out of a micro-VM would be something like this. Okay? And these things are disposable, instantly created and instantly disposed. And if you want, we can go and play with them. Typically, for something like an hourly in Twitter, you're going to see 4 or 5 different redirects, plus you're going to an untrusted.ly DNS. Each one of those is going to go in a separate one of these. Okay. Now, there's another nice opportunity here, and I apologize to Scott. I know he's sitting in the audience. It allows us to solve a problem which has persisted since 2008. You see, there's no notion of detection here. Everything from the outside is always untrusted. Okay? So the bad guy's going to show up at some point. He's going to show up. He's much more sophisticated than I am. And he's going to compromise the system. That's the definition of a zero-day. He will arbitrarily elevate his privileges, go into ring 0, stomp all over the OS, do whatever he wants. What can he steal? Nothing. Maybe the cookie file for the website I was at. Okay? What can he talk to? The untrusted internet at best. But if he came in on a PDF, he's sitting there pounding sand because there's no network. Okay? So, but the bad guy is going to show up. Now, there is a remarkable thing that Intel EPT gives me, which is that I can make these things execute copy on write for free using the hardware. So here's what happens. Any change is made to either user space or kernel state as this thing executes is going to be cached locally in the context of the running VM. Okay? So they're size 0. They grow over time on the basis of these changes. Okay? The bad guy shows up. Now, what can we do? Detection will fail. We know that, right? We should make that a pledge of allegiance as we all leave the room. Detection will fail. Ask for AV for free. Okay. What can we rely on? We can rely on the idiot in me. At some point, I'm going to close the browser tab or the document, and I'm just going to throw the whole thing away. So here is a desktop that always remains gold, that always throws away all malware, and that you don't have to patch. Alternatively, it's a desktop which allows you to use, as I do, legacy versions of Java. By the way, you can't get away from the Java problem. Okay? If you're using Oracle R11, you are restricted to a Java VM on the client that is no greater than Java 1.6. You're done. So why don't we just say, yes, let's develop a computing model which says that's fine, and it can never do anything to me. Okay? Now, the bad guy can't steal anything, right? So I'm just going to throw this thing away, and we'll just copy on write state. Now, that isn't the problem that I know Scott really has been wanting to solve since 2008, and that is this. Back in 2008, in Cannes, on the same day that we as XenSource announced, maybe it's 2007, that we announced that XenServer was free, VMware stood up the CTOs of all of the security vendors on stage and announced this amazing thing called introspection, courtesy of the acquisition of an outfit called Determiner. And they said this, that the hypervisor, courtesy of its business as the most privileged code in the system, could introspect and see execution in a VM. It would therefore determine the fate of malware detection in the future. And they were right, but in a completely different way. That is, this is a hypervisor. Now, in a traditional VM, there's a ton of stuff to watch. What crosses the boundary between a VM and a hypervisor? Blocks of memory, blocks of storage, packets to a virtual NIC. You try to figure out whether that's an attack. It's way hard, way hard. So nobody made any progress there for eons, for obvious reasons, okay? And there are still people out there trying to pick that one apart. But this is so much easier. Why? Well, what do I have in here? I have precisely one task, okay? And I know what the task is. It's IE, or a browser renderer, and it's facing the untrusted web. If you're in the detection business, like McAfee or Symantec, you have to detect early. You have to detect the bad guy before he does his bad stuff. But I just showed you an architecture where I don't care. Okay? Now, polymorphism makes it really hard to spot bad guys. The attack changes every time it runs. Okay? Which is why you get lots and lots of false positives out of those sorts of systems. I showed you an architecture where I'm going to say, I don't care what you do to this system, it will defend itself using hardware. So we can basically let malware run until it does something provably bad. It will hammer the system, at which point it's blindingly obvious. What is this thing on the CPU? It's a VM. All I have to do is pause it or kill it and look up the stack. What have I got? Every packet it sent, every DNS it ever talked to, every file it dropped in the file system, every registry entry it ever tried to change, everything it executed, every fork, everything it did. I have the full execution trace of malware that nobody could detect. And so it turns out that this is the way to solve the problem of introspection. It's excruciatingly granular, and you're using the hardware to protect the system so you can wait till the malware absolutely strikes. Okay? Now, I'm not trying to claim that one can build a perfect detector. Turing was right, he will always be right. But you can build a detector which generates 0 false positives. Okay? And you get introspection plus all the traditional stuff. Okay, so you can do some crazy things. So you can get a complete execution trace of what malware is doing within a micro VM. Okay, and you can do, you can see CNC centers, you get the botnet, you get absolutely everything you ever want to see. There's another really cool thing, which is that because you have the files that he brought in, you can generate SHA-1s and MD5s over the payload. Oh, that's a signature in IDS or IPS language. Okay? So the payload that the bad guy brought in to actually execute his attack, you've just generated a signature for it. All right? So there are some way cool things you can do with this stuff on a client. All right, so I'm going to just flip back to the consumer device argument here. We as a society are being absolutely and totally owned, okay, by determined attackers. Virtualization has allowed us to solve the delivery problem. It has not helped us solve the security problem. But the combination of these, and I'm sure that it will emerge in all hypervisors over time, because that's the way that the world works, can allow us to build systems that are inherently secure, okay? That will defeat things by design, okay? And that is a big step forward in terms of the way that we build infrastructure, okay? So how do we do this notion? So this is an awesomely cool system in terms of protecting itself. It will protect itself without any of your legacy network stuff in the enterprise, in the most dangerous place on the planet. Let's just call it Starbucks. Okay? By the way, that's where your user is. How do we get these other requirements met? Manageability, delivery, compliance. Okay? Because what I've now described to you is two possible value propositions that can arise from slightly different incarnations of a hypervisor, and we kind of want all of it, right? Okay. And so we have to do that. So back in the days when I was at Citrix, we built a thing called XenClient XT, and we built this, this system which basically did an attested boot. Now, you see in Windows 8, to get the Windows 8 logo, attested boot is a requirement. By the way, Apple does exactly the same thing on an iOS device. Any device vendor worth their salt should do an attested boot. Okay? It's just the right way to go. So hardware-assisted security is coming big time. Attested boot, number one. By the way, VMware does a great job of this for server-side hypervisors. They're the only one who does a good job of it, actually. Okay? And so we built this thing called XenClient, and we separated everything out, all the I/O and everything else, and so then you end up with these different VMs, and it was highly purposed for really an analyst who's going to spend time in one VM, and a trained user. Cool. Can we do something better than this? Well, the answer actually that's coming is a technology which has just been released in the Intel Haswell processors called VMCS Shadow. And VMCS Shadow, essentially the simplest way to think would be say, you can nest hypervisors, but there's nobody on the planet who wants to do that. By the way, the only hypervisors in the industry that today support nesting is VMware, and they do a fabulous job of it, okay? But what this would allow you to do is nest these different capabilities, okay? That is, you get hardware support essentially to extend the ability of all of the hardware virtualization support to an additional component which is also going to use it, okay? Nesting hypervisors, effectively. And so you can certainly do that on a XenClient TX platform. You could do it on a server hypervisor too. Gosh, there's no difference really, we all know that, okay? And so there's no reason why, if this was, say, VMware ESX, you couldn't have a nested security component, which would be a microvisor using something like VMCS Shadow. In fact, VMware does an awesomely good implementation of purely software nesting today, okay? All I'm saying is that the hardware is coming, and that will help, okay? Today with software nesting, there is a performance hit of about, correct me if I'm wrong, 10 to 15% in terms of memory density and or performance. Okay, but it's not vast, and that's VMware's always had a really good job of doing software features before the hardware is available. Think way back to their first binary rewriting technology, which they did a great job of. Okay, so what could you do for RDS and VDI? Well, the very simple thing you could do is basically insert this notion into VDI using RDS. That is, you could run this for RDS. Right, you could do this pre-Haswell. In other words, have a native implementation of an RDS server, micro-virtualize it, use the logs on, everything is sliced up into little micro-containers, and then you can inject that into your VDI world. Okay, that's step one. The next step then is essentially to have a generic hypervisor with VMs, and then use this ability to inject security, execution time security into VMs. Okay? So, what am I saying here? The future is bright. Hardware-based security is going to be the white pony that gallops into the room and helps us out here. It's all going to be virtualization. It's driven by the same core technology that you know and love, and that's a hypervisor. It's just an evolution of the hypervisor idea. This stuff would be very valuable cloud side too, for another reason. Okay, I'll just quickly cover the density argument. If your server is running, I'll use Hyper-V terminology because it's really obvious that way. Say you're Microsoft and you think everything's always going to be Windows that runs on this server, right? I've already got Windows running. It's called my parent partition, okay? Why on earth would I want more copies of Windows consuming memory on my server, okay? Essentially same thing, just the VM is a construct which is really just a bunch of pointers to things that are in memory. All of the operating system code that's in memory, it's in every VM. It's just mapped in, okay? All of the application code that I need, like IE, my examples, it's already in the VM. It's just a bunch of pointers. It's not occupying real memory, and then I can go do something. So in this way, you would get maximum density. Okay, so if you ever wanted to get maximum number of VMs possible on a hypervisor, this is the way you do it. The hardware limit today from Intel VT is 256 VMs per CPU. It's going to 1024. And we can get 256 VMs in under 4 gigs of memory. Okay? So when it gets up to 1024, that's when things get exciting. Okay, so you can build things that are secured by design. Now, I wanted to fly quickly through some use cases that Gabe and Brian were talking about. And by the way, I'm absolutely open to questions at any point in this. Scott.
Okay, so Simon, let me ask you a couple of questions here so I understand what you're showing. I see how your microvisor approach, you split things up into tasks, basically the unit, the exploit in any task to just within that task because it's a copy on write and you can resolve it on exit so it doesn't affect anybody else. However, most of the exploits today are about stealing data in some
Yes.
way, shape, or form.
Yes.
How is this preventing, if I've infected a given task,
Yeah.
memory image is changed, now executing in a corrupted mode,
Yes.
and it's going to steal something.
Right. So that gets answered by, so when you create one of these things, you create it according to strict least privilege. I create a tab in my browser for Facebook. The only file in the file system is the cookie for Facebook. Go ahead and steal it. Okay? That is what you get. Now remember, the Byzantine general can't guarantee that nobody's going to get killed on the battlefield. Okay? But the business of maximally disjointed, maximally distrustful tasks means that you minimize the loss, okay? And so if you lose the cookie for Facebook, I'm okay with it.
But how did I set in a given task that I was running Facebook? How did you know what was okay and not okay?
That's defined by the semantics of the web. For the browser, that's defined. That is, the DOM, the document object model, defines that, okay? This is what browsers do, okay?
So what if the Facebook page is compromised and sends you code that needs to access something outside of that? But are you saying it does a cookie because I look at what domain it's going to do? The browser is
So the browser DOM would basically say every single top-level domain is a different one of these hardware-isolated tasks, okay? And then the logic in there is going to try and get me, right? So the Facebook, I surface things for CISOs on Facebook because it's a perfectly targeted ad platform, and I surface logical malware for them all the time. Okay, so the logic, which is this application which is running this, a bunch of JavaScript and whatever else, running in my browser, is now going to try and attack me, okay? What does it have access to? The untrusted internet and a cookie file, and there's nothing else to steal, okay? It can compromise the runtime arbitrarily, don't care, okay? And now it's going to try and do something. It's trying to access a file or something. 10 minutes, thank you, okay? That's the point at which we need to enforce dynamic least privilege, and I'm going to get to that. So let me try that with you as some of the use cases. You okay if I blast at it?
Yeah, I had a different question. How does the user install?
So technically so the nice thing about this, so the real problem with client hypervisors has been, oh crap, how am I going to install it? Certainly from type 1, which would arguably be the most secure, it's a nightmare.
How do I download an application from the net that is useful to me, an application, and install it?
Yes.
Where it may install drivers or other things into the system that inherently I believe you're trusting because you're using the drivers. You said you rely upon the drivers that are already there in Core
I don't trust anything, okay? So,
Okay, but how do I do that? How do I install that and then have it persist?
yes.
If you're going to throw it away, right?
So-
Would that be a new task?
Yes, the answer to that is actually very interesting. First of all, from a hardware perspective, you want the ability to maximally deprivilege the operating system that was there and to start with. So if you think of the feature set that's in vPro today, that's kind of what you need. An IOMMU is really fundamental to protecting the microvisor from attack and so on. All right, now, if you download some random.exe and execute it, it's going to arbitrarily permute the system and create changes. Sure, I can let you persist those changes. I can let you do whatever you want. Every time you run it, it's going to be in one of these. Okay? That is, if you think about Strata apps,
How do I actually update the core OS? I mean, you're fundamentally
using the
running-
patching tools that Microsoft gave you, using Microsoft Windows Update or anything else.
To your point, as soon as those are compromised, because the bad guys will go, oh, well, I can't get it the traditional ways. So as soon as that compromised, I can compromise that core layer, and now I'm cloning
Yes.
a compromised copy
So,
of the OS.
all right, so now you're asking what are the remaining vulnerabilities of a system like this? So why don't we just go and describe that, because otherwise you'll pick me apart forever. No, it's much easier just to tell you. Okay, so the remaining vulnerabilities actually, so there's something that the VMware folks would hate, but in fact not in the case of something like Fusion. If you look at this Pi model, what I've said to you, so technically this is a late load hypervisor, okay? It drops in, reaches down, grabs VT and anything else that it can, and goes to work. Okay, so we avoid the problem of installing a hypervisor. We get all the benefits that you would get, say, out of installing something like Fusion, which is great. What are the remaining vulnerabilities? Well, on the LAN, what drivers are picking the packet up off the LAN? The drivers from the OS, okay, which are from some vendor. Here, Microsoft, could be Apple, could be, that's absolutely a vulnerability. If there is a kernel bug there, we're done, okay? But that's true for ESX or anything else. For any system which is going to have that, where you finally end up with some software, that at that point you're vulnerable, okay? And you know, where else are you vulnerable? You're vulnerable, well, potentially you're vulnerable if the bad guy now wants to, so you're downloading a file, or whatever, right? So you download a file and you want to save it. You download something from Facebook and you want to save it. That's malware. But remember, we own all the gazinters and gazatters of this thing at that object level. So all you have to do is wrap it up, interesting problem, and know that you'll never touch it, know that you'll never trust it, and then any attempt to ever consume it puts you back in one of these. And by the way, that has to survive on any file system. That's not an easy task in its own right, okay? So you cannot solve the dynamic least privilege problem without an ability to deal with the fact that you also need to do copy and paste or print. And my printer is on the high side of the system, okay? And so whenever you do something which forces you to cross that boundary, you have to be in control, like the general has to be in control of all communication. And if, say, you want to print, at that point you have to use trusted code, just flatten the document into an unthreatening format, drop it as an untrusted component, and then send it just to the printer on the high side, okay? Copy and paste, interesting because it's asymmetric. Copy high from low, high to low, low to high. Again, you have to do, if you have to do data transformations, okay? But I can let you run anything in one of these. It's totally cool. That is, you can run an arbitrary exe, which arbitrarily modifies the system. The business of persisting it is interesting. And so, and I think this is going to deal with one of the challenges Gabe and so on brought up earlier. So let me show you the collaboration use case, which I think is profound. You see, what we've got to with the Microsoft Trusted Computing Initiative is that ultimately we rely on the user to make the decision. That is, you know, we all collaborate with people outside the org. Okay, and so you can encrypt stuff all you want. The moment you give it to somebody else through Dropbox or copy and paste or putting in an email, that's when you lose it. So the challenge, if you just, let's just assume we're just doing Word on a traditional workflow, the problem is this, and this is where Microsoft Trusted Computing Initiative has got to. It's got to this point, which is you're going to get this banner which says enable editing. This came from a bad place. Now, this is vulnerable already, okay, to my font loading problem that I described earlier, okay? And it has this additional problem with that it's relying on the user as the last bastion of security, okay? So the moment you do this, you're definitely changing his privileges and the trust level. If there's a bad guy, he can hop out and do things to you, okay? So we don't want that. So what could you do? Well, by the way, there's another problem, which is this: every time we collaborate on a thing, we're gonna, as I send it to you, you're gonna have to click on enable editing and so on, right? And so we end up with this thing which is train the user to always click OK. By the way, has anybody here in this room ever not clicked OK to Microsoft Windows UAC? Right, got it. Okay, so we train the user to always click enable. And so that's a problem. So if you put the document into an untrusted hardware isolated task, you can give the user the full user experience of the application. And you can get past this problem, which is like, hey, user, you've got to be the last bastion of security. You've got to decide if it's good or bad. Users don't edit untrusted documents. They are pretty good at figuring it out. But by the way, you're still never going to trust it. So you send off to somebody else. Another problem, if the guy on the far side does not have anything, you just on a standard desktop or some other standard device, you can't muck with the data format. Okay? So anything that you remember about this thing has to be independent of permuting the data. You cannot do that. Otherwise, you screw up the guy on the other side. And so we come to this problem which Brian and Gabe set up perfectly, which is that there is a need for some metadata tagging on data which will persist forever. They spoke about it, which is in a different way, which I think is very relevant to the Windows Server 12 DAC stuff, which is part of the file system, which is that you can arbitrarily attach tags which indicate the relative importance of your stuff. But you could also attach tags which say, this stuff is from the outside, I will never trust it ever, but I can still let you use it in ways that are productive to you. Okay.
As long as I can find a way to tamper with the metadata, I can get around it too.
Yes.
It's going to be well-known formats for interoperability.
But you've got to get to the point at which the metadata is manipulated, and that's on the inside. So if you get on the inside, you can take any system. The problem is, how do you get in? Okay?
If I get in before I've installed my microphone, I mean, at the point microphones
Yes.
are installed, are you assuming it's a secure system? Are you validating them?
This is the problem of any software base, right? Any software base has this problem, which is, I can do an attested boot using ESX, but do I know that that's really ESX? Yeah, so attested boot is going to be a key component here, okay? But attested boot can't check every file in the file system. Okay, so you get it. But can we make the world a lot better? Absolutely, and we can combine these in the hypervisor. So the key thing that I'm trying to do here is to say, look, the stuff that your security vendors have been selling you for years is a pile of nonsense, okay? You should say WTF to them, and I'm not prepared to buy it anymore. And the key thing is that this community that gets these core technologies is going to help to solve the next problem. And I think we can get big steps forward by going down a path like this. And you'll see it show up in all these hypervisors over time. Any other questions? Yes?
Time for one more question.
Can this technology at all address the denial of service attacks?
There is a potential application of this on the cloud side for that, yes. Now, what is doing the scheduling here? In ESX, there's a scheduler. In XenServer, there's a scheduler, right? That thing schedules the VMs and decides how to hand out resources. In this thing, the operating system is deciding how to schedule, okay? So there are some really cool benefits. For a start, today, so yes, you're potentially vulnerable to that, right? That is forking off bazillions of course, you would never let a task create bazillions of additional hardware isolated tasks. That's an easy one to stop. That is on the client side. On the server side, could you use this to help solve that problem? Yes, you could. But to be perfectly honest, there's a lot of thinking that needs to be gone through to find the ideal server-side implementations of this. And I wouldn't claim to have done that yet. The scheduling of tasks is just done by the operating system, as it always has been. The awesome thing about this is, if you want to run some app, some complex numerical crunching app, it's just running in the operating system too. It will get the right CPU. Okay. So you have the benefit of a good operating system scheduler sitting underneath you. Any other questions? Scott, I know there's one.
I just want to make a comment about the comment you made earlier. With anything in security, it's degrees.
Yes, absolutely degrees.
How much you made about the VMware, about VMworld 2018
Yes.
The advance that that made was that, number one,
Yes.
move the protection logic out of the address space of the VM.
That's right.
Advance. And the other thing that it did was introspection that time was about freezing the VM that had been compromised and analyzing it to figure out the compromise.
Yes. But I'm going to follow this up with a challenge, okay? The security guys don't get it. They're useless, okay? You are VMware, go fix it, okay? That is, I've always said that it's absolutely, then you own every enterprise data center that I've ever been into. Go fix the bloody problem, okay? You have the ability, you have the technology, go fix it. That is, the virtualization guys can do this. We can make the world a better place.
We are out of time.
I'll stay here for a bit.